Okay. So set interval and set timeout. These are asynchronous so that they can perform logic repeatedly or after a delay. So set timeout is the ability to write some code and delay it. So you might want to make it so that it executes after half a second. Maybe you want it to execute after 10 seconds. Again, it doesn't really matter when it's happening, but essentially you say, I want this bit of code to run after a certain amount of time. Same thing, set interval, except this will happen on an interval, so you can make it happen every 2 seconds repeatedly. For example, you could like ping a server, some sort of event that you want to happen on a regular basis on a specific time. So if these were synchronous, you'd be stuck in a loop or a queue until they're completed. Obviously, that would not be great. You can think of it almost like being stuck in a while loop that you never, ever end up closing. So it's kind of a similar idea. The other thing is the last common one is events. So JavaScript in its core originally is an event-driven language. So what this essentially means is I'm sure you've added button click listeners and stuff like that. So when you have a button, you usually register an event. So that could be a click event, focus event. For the window, you could do a scroll event. And what you essentially say is, when this event fires, I want to execute this code. So that code is not running continuously. It only happens when there is an event that gets fired, such as click, mouse down, etc. So an example here is we have a function that's called sayHi. So in it, you can pass a name, and then we console log out that name. So in the first example right here, this is blocking code, which basically means that it will console log out Keval before it does Devin and then before Connor. So basically, each statement has to wait for the previous one to finish before it can execute itself. However, down here, we have a set interval. So we have sayHi, and then we say 2500. So this is 2.5 seconds. And then we pass in Michael. So what will happen here is these two lines will not be executed first. It will actually execute sayHi with Daryl and then Ilya. And the reason for this is set interval will wait 2.5 seconds and then do Michael. And so yeah. So essentially what it does is it just delays itself in order to execute code that is on the next line. So a way that we have dealt in the past, in earlier versions of JavaScript, is to do asynchronous programming, we use something called callbacks. And for those of you, some of you might have heard the term callback hell. This is basically what happens when you pass several different callbacks over and over again, and you get this very nested structure of callbacks, and we'll scroll down to see it. But callbacks, what it does is you pass a function as a parameter. So in other programming languages, you might not have done something like this before. Usually you'll maybe create a class and then execute different functions within that class or some sort of different way of dealing with different code. But in JavaScript, because we can't delay something till later without using a timeout or an interval, what we do is we pass a function as a parameter. So an example right here is we have a function called farewell. And we also have another function called greeting. So what greeting does is it console logs hello and then the name that you pass to it. Notice that there's a second parameter called callback. So what we do is we just execute it like a regular function. We call callback and then pass in the name parameter, which when you see right here, so we have greeting. This is using Sean McKinnon because he so kindly shared this with me. We have greeting, we pass in our name, and then we pass in our callback, which is farewell. So farewell will not execute until after we console log name, and then we call the callback. And then right here you can see up here, farewell, goodbye. So if I were to call this, and you can actually just paste this into your browser under the console log. So I'm going to zoom this in just so you can see it. So if I paste this, whoops, I should have been under the right one. So let me just clear this. So clear. paste. So we get hello and then goodbye. So this is a way that we've been dealing with asynchronous code for a long, long time in JavaScript until a little bit more recently, which I'll get into it. So what this does is we have code separation and modularity, which basically we can split our functions into different, our code into different functions. So because of the priority, obviously we run this code first, then we run the callback that we pass to it second, but we can do this with as many callbacks as we wanted, which would start to get pretty ugly over time. So using a callback for asynchronous operations, this is an example using an HTTP request. So what we do is we have a URL where we want to grab some sort of data from it. We don't know how long it's going to take. It could take, like I said, half a second, 10 seconds. We have no idea of knowing. So what we do is we pass in the URL that we want to make a call to, and then we pass a callback. And that callback is just a function that ends up returning basically this call right here to the URL that's up above. When it completes, it will pass the value of what it received into this function. So we get back the client. So the client is what is returned when we do a call. So then we have our client on data. This means that our HTTP client has received data, and then it returns back data. So you can see right away we have our first callback, our second callback, and then we have a third callback where we pass callback data to string up here. So why do we go through all of this? Reason being is we don't want to hold back other parts of our JavaScript code. So an example that I could show you would be, so if I did a for loop, and I'll just do let I equals 0, I is less than 100, I plus plus, and I'm just going to console log I. So okay, so we printed 0 through 99. But if instead of doing console log, I did an alert, so I'm going to do an alert, and then I'm also going to console log I. So we want to do both. We want to alert, and then we also want to console log. So when I hit enter, we get an alert. So I hit OK, and then you see that it prints 0 and it stops. So this is an example of a blocking bit of code in JavaScript. Basically, the next line will not execute because something's currently still happening, which is really annoying to deal with. So we hit OK, and then 1, and etc. And I'm just going to refresh because, yeah, there's no way to get, I'm just going to hold enter. OK, so now we have to wait, and this is also really annoying. So we'll get all the way up to 100. I should have chosen a shorter number. But anyway, OK. So that is essentially what ends up happening, is we have to wait on the previous bit of code to finish running before we can run any other code. Whereas with this, what we end up doing is we do a call, and then we say when that finishes, we want to execute this code. We don't want to have to wait around and wait for this guy to come back and let us know what happened. We can just do some bit of code when it comes back. So the above is a good example of callback hell, a term given to code that uses a large amount of callbacks. Lots of callbacks render the code difficult to read, as you can see. So this is honestly not that bad. This is only 3 levels deep, but depending on the type of application that you're working on, you can sometimes get several different layers. So what is pretty common in different bits of web development is we'll do one API call, and then we have to wait on that response to come back so that we can figure out where to do a second call. So we have to wait on the response of the first call before we can do the second call. So if we have to do that several different times, we would have 3 callbacks here, 4th callback there, and then you can imagine for every single API call that we're doing, we'd have to do the exact same thing. So it gets very complex very quickly, and there are much easier ways of dealing with code nowadays. So in comes promises. So for who here, by a show of hands, is familiar with hearing the term ES6? Couple hands, good. So what ES6 is, and this is, we'll get into it here. So ECMAScript is the specification of JavaScript, and it goes through several different versions. So previously, we had to wait a huge amount of time before we get different versions. So here's the different versions. So version 1 originally came out in 1997 in June, and then version 2, 1998 in June as well. So we had to wait a full year before we got any new features. Then December 1999 for version 3, and then version 4 was abandoned. They ended up just going to version 5. But you can see the difference, December 1999 and December 2009. So can you imagine working on a programming language that has 10 years before you get any new features? So this was a pretty big deal when they got version 5. And then they had to wait an additional 3 more years before they got 5.1. So even just small changes to the language. And then lastly, ECMAScript, which was in 2015. So you can see that there's large jumps between the language, which the reason why I'm saying this is promises were a pretty big deal when they originally came out. Before everything was with callbacks or using event streams, all that different kinds of ways of dealing with asynchronous code. But in comes, in 2015, ECMAScript 2015, also known as ES6. So the reason why there's 2 different names for it, there's ECMAScript 2015 or ECMAScript 6, and the reason for this is we are now going to a yearly model. So instead of having to wait 4 or 5 years for a big version to come out, what they're going to do is go into smaller chunks. So you'll get fewer updates more frequently, which will make it a lot easier in order to swallow like the new changes. So promises were one of the updates in ES6. So what they're made for is for helping deal with callbacks and just make stuff more readable. So by encapsulating our function logic into a promise, we can then provide 2 new methods. So what a promise is it's an object that will either do what is called rejecting or responding or resolving. So you can think of a promise as like a regular promise. So you say to someone that you're going to promise them that you will come back, I don't know, if they give you $5, you'll give them $10 next week. You promise. So obviously there's either 2 things. We as programmers like to boil stuff down pretty basic. That's either going to be true or false. I'm either going to give you $10 next week or I'm not going to give you $10 next week. But you have no way of knowing. You have to wait an entire week to find out. So what a promise does is when we respond back with a result that it's expecting, that's called resolving. So in a week, I gave you back your $10, everything's all good. However, if we reject, then that means that our code is getting something that it's not expecting. And in some ways, you can think of it as we expect the unexpected. So when we reject, this means that our promise did not get the result that it's looking for. When we do a network request, that could be like a 404, maybe it's a 500 error, we don't really know. That's why we have different standardizations when it comes to programming. So we have a function that's called .then, and this is code that will execute when the promise resolves. And again, we also have a .catch, which is kind of similar to in other programming languages. You have a try-catch. This is the code that ends up getting executed when the promise rejects. So an example, this one's a little bit more complex. It does get a little bit easier, which you'll see. But we have a new promise. And this, you can see right here, is a callback. So we have our function, and it resolves or rejects. But when we create our connection, and we say const req, which is going to be our request, is this call right here. So we have our request on error, we reject, and then up here, we resolve our string, our data to string. And we can do different things to make this more promise-like. But down below, when we get our insult, we have a .then. So get result, then console log the data, otherwise catch, and console log the error. So this is a lot nicer of dealing with asynchronous code because typically what would happen And you'll see this in other languages. Go is a really popular language that does this, is it will return two different objects. The first one will be your data object, and the second one is an error. So what will happen is we always have to check if that error object exists. So we'll say, in the case of Go, if nil equals the error, then that means that we don't have an error. Otherwise, we could also check the opposite. But what we can do is we can just separate out that logic. We don't have to have an if statement to check, is there an error, is there not an error, do this, do that. We can just separate them into two separate functions. And in here, if you're not familiar, this is what is called an anonymous function. So this means that we have not declared it in the upper scope. We've just created it right here, and it will execute it as needed. So the other benefit of working with promises is that they're chainable. So for those of you that have worked with jQuery or other sort of other frameworks or front-end libraries, I put my hands up because jQuery really isn't a front-end library, but essentially we've had nice ways of being able to chain operations on the same thing. So in this case, we could do getInsult.then, and then we could return another promise in here and continue to chain multiple thens over and over again. So I can't run this just because this is on the node side using the HTTPS library, but as you can see, part of this is still kind of complex. So there are still callbacks that you're having to do, not in the same way, but you still have all these anonymous functions all over the place that are doing things that is still complex. Also, there's not a quiz. This is just set up from before. There's no quiz today, so don't worry. But one of the things that made this easier in a more modern version of JavaScript is what is called async await. So async await is a layer on top of promises that ends up trying to make your code look more synchronous with asynchronous calls. So originally we had a break here. I'm just going to keep going, and then we'll go on a break in a second. So yeah, one sec. Okay. So as I mentioned before, ES6 is the standard for ECMAScript 6, or ECMAScript 2015. So ECMA is an organization that standardizes information. Because JavaScript is implemented differently in various browsers, there has to be a standard and specification that they must follow to ensure that developers have a common environment to work with. So that's kind of the big thing that's different than other programming languages that you might be familiar with. So when you have the .NET framework or you have Java, the makers of that programming language get to dictate what are the features in that language, and then you download either the runtime, or you download like the SDK if you're wanting to compile in it. But JavaScript, of course, like everything else, is a little bit different. So you have Firefox, you have Google, you have Edge, Internet Explorer, all these different browsers, Opera. I mean, the list honestly just grows daily, but each one of them is responsible for implementing their own way of compiling JavaScript. And also they're responsible for what features they support in their browser, which is quite annoying. Reason for this is we as developers don't like to write things twice. We also don't like to handle edge cases. We just want to write something once and it just works. So the thing that ECMAScript is it's the standardization of what is in the language. So that, like I said, you have ECMAScript 6, you have 5, all these different versions, and they say in order to be compliant with this version of JavaScript, you have to support these features. So, right here. So, updating the browsers to support every new standard can be costly because at the end of the day, even though that some of these companies are billion-dollar companies, it still takes a fair amount of time to make sure that all of these features are performing correctly in the browser, that they're optimized on different versions. Obviously, we have mobile phones, tablets, computers. We have to make sure that the features are performant across all devices. So it can be quite costly. And therefore, browsers adopt when they choose to do so. They also aren't required to update old browsers with the new standard, so it's very possible that new code will not work properly in older browsers. Hopefully most of you will know that trying to write code that works in Internet Explorer, even trying to write code that works in Internet Explorer 11 can be quite annoying. You end up having to write an older syntax of writing code, or you end up using sometimes complex tools in order to what is called transpile your code into older versions. And what ends up making this complex is you end up having to set up all of these different tools so that way you can support old versions. This is why JavaScript is, a lot of people don't like writing JavaScript, but I promise you, hopefully by the end of this semester, you will at least have some sort of appreciation for JavaScript because it can do a lot. So as I mentioned, there's something called transpilers. So transpilers allow us to use newer code functionality regardless of support for that functionality by transpiling the new code into legacy compatible code. This means that older browsers and browsers that are taking their time will still work. So it uses what is called polyfills. So a polyfill basically is if the browser is not going to write code that supports this feature, then I will write my own code in JavaScript that will support the feature. So we run it through, one of the most popular ones is called Babel. So we use Babel to transpile our code from modern code into a little bit older code. We can specify how old that code needs to work. So typically what is common nowadays is we support IE 11 plus, and even then I wish that I didn't have to support it, but we have to. However, we now have an extra step in our process. We have to transpile in order to ensure we are cross-browser compliant. This isn't a big deal, considering we can add transpilers to our build process, which will result in us always having cross-browser compliant code, regardless of what we code. So this is the thing. When it works, it works. When it doesn't, it doesn't. And it's a little bit annoying to set up as a beginner, but most projects, most likely when you go out into the workplace, will already have this set up. So an example of this is in ECMAScript 6, they introduced two different ways that you can declare variables. There's now const and let, which are a little bit different than the var keyword. So up here, we have var myScopedVar equals Bob. So does anyone want to maybe offer up what they know is the difference between, let's say, var and let? Yes.
Let is block scope, whereas var is function scope.
Correct. So what does that necessarily mean?
You can have blocks inside of a function, which means that let would be able to get outside of that, whereas var would be accessible throughout the whole function.
Correct. So to explain that, basically when you have your braces, any variables that you declare with let and const will only exist in between of the curly braces. However, when you have a var, if you had curly braces inside of this function, let's say an if statement or some other form, maybe a while loop or something, if you declared var inside of that, it would still exist inside of the function and still be accessible. So the reason why this is a big deal is sometimes we want something to only exist temporarily. And you can just think that let allows us to create a more temporary variable than a var. It also sometimes helps reduce any sort of errors. So if we create a for loop using, like let I, which is pretty common for creating a for loop, we use the variable I and it only exists of the duration of that for loop. Whereas if we were to use var, it would actually what does called hoisting, where it would then hoist our variable up to the top of our function, and then that variable would be able to be accessed at all times. So if we tried to console log out, sorry, there's a fly here. If we tried to console log out the variable I after our for loop using var, it would still exist after that for loop, whereas using let, it does not. So why does this matter? So we want to write code that we know always works. So when we use transpilers, what it will do is it will look at code like this. So we have our braces, we have a variable called let, and it's assigned to Bob. And what it does is it will convert it into what is called an immediately invoked function. So what this does is it wraps it in a function because var is function scoped instead of block scoped. So this is just a small example of doing transpiling to make it so that our code is more, like the source code is easier to read because obviously we don't like writing code like this. So immediately invoked functions are commonly used to maintain block scope. You'll see it in a lot of older code or even in stuff like jQuery and stuff like that. So that way we don't have variables that end up escaping and becoming global variables in our code. So one solution also with this that's quite nice is arrow functions, which also came out in ES6. The reason why I'm explaining all this, just so you know, is Node does support all of these modern features, so we don't have to worry about writing older code, but it's also a good idea to understand how it works because most of the libraries that we'll be using implement these kind of things. So just to quickly explain that. So arrow functions are very handy, and not just because they're shorter to write than full functions, but they also maintain the scope of the keyword this. So this is a keyword in JavaScript that can be tricky sometimes to explain. Many languages use the keyword this to represent the current scoped object. It gives you access to define properties and methods, and is fundamental to object-oriented programming. However, in JavaScript, this changes scope to reference its current function container. This means if you call this from within a callback, it is referencing to its callback and not the surrounding function. So this is the actual keyword this changes what it's representing depending on the code that's being executed, like in a callback. So an example here is we have a function called person. So this is an older way of declaring a class inside of JavaScript. So we have a function called person. So what we would do previously to get this, meaning the reference to the person that we have, is we would assign a variable to that reference of this. So var that equals this. The reason that we do this is when we have this set interval with a callback, when we try to call this.age, it's not able to access it. It doesn't exist because it tries to reference just the function that's right here. So in this case, function grow up ends up getting called, and this is not defined, basically. Or at least age on this is not defined. So what we do is we capture the variable of this and assign it to that. We set that.age to 0, and then we do a set interval so that every 1 second we increment the age and then log it out. So that would be equal to this. We create a new person and assign it to peep. So if we were to execute this code, so you'll see that every second it ends up incrementing the age and then console logging the age out. So if I were to just quickly refresh and then change it so that way we were just using this, you'll see that we get not a number. And the reason for this is we try to increment what is undefined, which ends up being not a number, and then we end up console logging out not a number. So, yes? Sorry? Yes, 1 second. So, rate, so person and person, like this. So we still get the same thing. Because the reason is we're defining a new person. So it's creating an instance of the person object. So instead of it's not a static variable, it's the opposite of static, sorry. So essentially it still tries to do the exact same thing because it doesn't have a reference to that newly created object. So you'll see what is more common in modern code. We actually do have classes that we can define in ES6. So we can create a person, we can create a constructor, and we'll say this.age equals 0, and so, let me just, so, get age is going to return this dot age. Let me just refresh. So okay, so var person equals new person, and set interval code that we want to write is person dot get age, and we want to run it every 1 second. So in this case, it is, why is it? That's weird. I don't know what's going on there. But essentially, using the class of ES6 classes does solve some of those problems, so you don't have to capture the current access to that class. It's only when we start actually passing around functions as parameters that it does start to complex it a little bit. So, not promises, let's scroll back down. Okay. So many programmers have overcome this, as mentioned, by assigning this to that or self or some other arbitrary variable that will maintain the scope. So this isn't ideal because obviously one of the main principles of programming is dry, which is don't repeat yourself. Do you have a question, sorry? No, okay, sorry, just double checking. So the above may seem odd, but it's essentially a class with a constructor. So the constructor is setting up the property of that equal to this, so it will maintain context when given to the callback function grow up. Otherwise, grow up will throw a reference error when we attempt to access this.age, as it isn't present within its context. The big thing is that browsers try to be smart for us, so you could see that it wasn't necessarily throwing an error, it was just returning not a number. So that's kind of one of the things with JavaScript, is that the browsers will try to interpret the code that we're running and try to be smart for us and not throw any errors. But obviously we're not getting the result that we want. Below, we attempt the same example, but instead using the arrow function. So something that is quite handy in ES6 is that when we use an arrow function, it will automatically bind this to that arrow function. So instead of, another thing that you could have done is on here we could bind this and basically say, I don't like the word this just because it's hard to explain, but if we attach this to the function that is being executed right here, it then allows it to know the context of it. So another thing that we could have done up here is to show it off. So instead of this, I'm going to reference this. Let's just remove the comments so they're out. And then I can do dot bind this. So we pass this, we bind the function, already declared, refresh. Ooh. Oh yeah, I do. Thank you. So that also works. So we can bind this to it, which again is not exactly the prettiest to look at, but what we can do is just by using an arrow function, it will automatically bind the reference of the person to that function right here. So this property refers to the person object, and it just makes it a little bit shorter for us so that way we don't have to set stuff up manually. In the above example, we pass an arrow function as a callback. The arrow function maintains the context of this throughout the body of the function, which is much cleaner, much easier to read. So arrow functions can be a little confusing because you will see them in different syntaxes. Below is a table showing you the various ways you'll see them formed and what they mean. So here is the first example. So this is a function that has two parameters. We have param1, param2, and it returns param1 plus param2. So the braces hold the parameters. The arrow then passes those parameters into our function block where we are then returning them concatenated. So you can see it's like a regular function. where we have the opening brace, the closing brace, and we have a return statement. Now, something that they possibly overcomplicated when they created this is when you only have one parameter, it is optional to put the parentheses around it. So you can actually just put the variable by itself and then using the arrow function and return. So in this case, you can forego the parentheses. Now, something else that you can also do is instead of putting the curly braces around for your function, you can actually forego the return statement and say exactly what you want to return. So this would be a pretty useless function because what it essentially does is you pass in a parameter and then it just returns it immediately. Not very useful, but it allows you to write shorter functions. So in this case up here, we could actually remove the braces and remove the return statement. So we could just say return param1 plus param2. Again, don't know why you would make a function that just returns two things added together, but you can. So the other one is, and this is partially where the complexity increases, is if you have no parameters, you do have to include the parentheses. So here's my bit of advice. Always include it, just because if you don't need it, then you just did it anyway. But it will reduce some of the errors that you end up typing in your code. So just always include the parentheses if you're doing an arrow function. In this case, we're not passing anything, so we just return h1. Or sorry, we're just returning hi. It looked like a 1. Or without using the return statement, we can just use the parentheses, arrow, and then hi. The other thing is this is the last example is another instantly invoked function. This function will automatically run and not be executed. It is most commonly seen when either encapsulating scope or creating an async operation. So this doesn't end up returning anything. It's basically if we wanted to initialize something for our application, but we don't need to attach a variable or a reference to whatever that function is returning. So this is a way of basically just having something that we initialize kind of floating in space, or in this case, creating an async operation. So the other, sorry. As mentioned, ES6 was a pretty big deal when it came out. There's a lot of stuff that's added to it, so in some cases, I know the previous class did not go over any ES6 syntax, so if some of this is review for you, I'm sorry. But one thing that I do quite often is I use a lot of the new functions that they added to the array type. So who here knows what mapping is? You want to explain it?
It's basically taking one array and mapping it to a new array with the values into the new array changing.
Yeah, so one way of kind of like explaining it is you can think of it like a for loop, where you loop over everything that's in there, but your map will always return a new array. So sometimes what is quite common of what people show off for mapping is, oh, this is still going. Okay. So I'm going to create an array that's going to have 1, 2, and 3. Then I will map over it and return the val times 2. So you can see right here that I've created an array with the values 1, 2, 3, and then I map over them, and I say val, this is my arrow function, val returns val times 2. So you can see the array right here that it returns is 2, 4, and 6. So sometimes what people try to do is they try to use map and they want to exclude something from an array. So an example that you could do right here is you could say if val is greater than 2, or let's actually do the opposite. Let's say if val is less than or equal to 2, return val. So what's here is we have our first value, because it's less than or equal to 2. We have our second value, still less than or equal to 2. And then the third value, which is going to be greater than 2, is undefined. And it's because a map will always return a new array of the same length of what was originally mapped over. So there are different things that you can do instead of map. There are lots of different functions. An example that you can do instead of mapping is you can do what's called filter. So you can say dot filter. Let me zoom this in so you can see for sure. Turn that off. So I can say I want to return where the val is greater than 2. So in this case, I can filter on this array and only return values that are greater than 2. I could also do the exact opposite. I could say less than 2. I could say less than equal to 2. So there were a lot of new syntax, a lot of new functions that were added onto the array type that right here, that you'll see me use several different times in this class. So this type of programming is not what is called event-driven programming, which is what JavaScript kind of started as, but this is more getting into a type of programming that's called functional programming. So for me, writing functional programming is probably my favorite way of writing programming. I don't like writing classes. I don't like, polymorphism and inheritance and all of that, because honestly, it gets very complex, and quite frankly, in my opinion, it's kind of a load of shit. Dealing with just data is probably one of the easiest ways of dealing with code, because when we map over something, we end up maybe manipulating the data, we end up changing the data, but we don't have to create a new version of it. We don't have to create a person object, or we don't have to create, a human that extends of type this, that extends of type this, that extends of type this. JavaScript is kind of more going towards this, but is not the most. There are other languages that do functional programming in a much better way. But the reason why I think that functional programming is a lot easier to deal with is typically it's more expressive of what you're trying to do. So without the knowledge of understanding what map does, you might not be able to understand what this function does. However, even by looking at it most likely as a beginner, you can still kind of understand what's going on. So you can see that we have an array with 3 values in it, and we say map. And we have n, might not necessarily know what n is right away, but we console log n.length. And I'm like, okay, so length is referring to something. Typically a length is on a string or an array. So we are essentially logging out the length of each string that is in this function. So yeah, so that's one method. There are a bunch of other ones on the array type. And this will probably be the last thing that I do just before I let you guys go on break. So one of the major pain points, in my opinion, of dealing with strings in almost any language is trying to inject variables at a specific point. So I showed you guys last week, when you use the template literals as a part of JavaScript, you can inject any sort of valid JavaScript at that point in the template literal. So right here, we have a variable called name with, again, Sean McKinnon as the name, and we have an age of 39. So down below, we have a text where we inject the name variable, and then we also inject the age variable minus 20. So it's in here, we're just injecting the variable, but then right here, we're also injecting any sort of valid JavaScript. So it will take the age property and subtract 20 from it. And then we console log that text. So what is pretty cool with this is instead of having to break our string up into several smaller strings and then concat them together, we can just make it one continuous string and then be able to inject our variables as needed. You might have seen it in other programming languages where we use something like printf, where we want to print a formatted string, or sprintf, I believe, is in C, as well as PHP. There's tons of different ways of doing it. But in my opinion, this is one of my favorite ways of injecting stuff because in your editor, it's very quite obvious that you are injecting a variable. I'll show you right now, just in my editor. So if I make this JavaScript, you can see right away that I've created my variable, the two variables at the top, and then I have my string right here, and you can see right away that these are variables that are being injected in. Otherwise, what does get quite ugly to look at is I have text, and I want to say name plus, and then a space, because there's no space as a part of the string, is, and then another space, then age minus 20 plus space years old. And you can see that already the top line is a lot, or not a lot, but it is shorter than the line just below it. So as we start to work with lots and lots of strings, you can see why this would simplify part of our logic of being able to inject variables into a string. So yeah, so that's it that I'm going to go over for just before the break. When you come back, who here has not installed Node onto their machine while I've been going through this? If you have any issues, I can try to help you out on the break. But what we're actually going to be doing is taking some of these things that we're learning and be able to actually apply them, because I understand that some of this is quite boring, but unfortunately it's some of the stuff that we have to get through. So with that, if you guys want to be here at 7:15, and then we'll continue from there. Otherwise, yeah.
So question for you.
Yes.
So the state of the industry right now.
Okay. Let's roll through this. Okay. So before we start working and actually running a node project, the first thing that we have to know is npm. So just to quickly explain, npm stands for the Node Package Manager. So a package manager is used as a simplified way of adding, updating, and removing modules that are in our code. It has a API, or sorry, some other like examples of package managers is Brew, which is used for installing different applications or dependencies on Mac. Yum, Yarn, Ruby gems, if anyone has used Ruby before, Composer for PHP, wget is used on Linux. These are all different examples of package managers. So npm is the preferred package manager for Node.js, as it comes with it when you install Node. npm has the following main features. So it has a registry of packages to browse, download, and install third-party modules, which you can view on npmjs.com. You can search for packages that will help your application, and packages are solutions that can help mitigate reinventing the wheel. It also comes with a CLI tool to manage local and global packages. This is accessible through your terminal or command line tool of your operating system. So if you're using Mac, the default is terminal. If you're using Windows, then you can use the command line. Same thing on any sort of most Unix-based operating system is just called terminal. So you can check if it's working by opening up your terminal, and you can type in npm, and you will have a list of the different commands that are able to be run. Obviously, if npm is not working on your machine and you type in npm and you don't get this, then it is not installed correctly. So just make sure that Node is installed on your machine. So again, how do I get it? Just install Node. So when you're using npm for the first time in a brand new project, the command that you will write, kind of similar to using git init, is npm init. So we initialize our project using npm. So why do we do this? It asks us a couple questions about our project. So I'm going to quickly go into a directory. So I'm going to create Monday, cd into Monday, and create week 3. Okay. So I'm inside of a folder that I've created on my computer, and right now if I ls, it's empty. There's nothing inside of it. I don't have any files, no folders. But what I'm going to do is I'm going to type in npm init. So npm init. And again, what this does is it initializes our Node project. So as you can see, it says this utility will walk you through creating a packaged JSON file, which we'll go over in a second what that is. It only covers the most common types and tries to guess sensible defaults. So you can run these other commands, but not really as important. So right now it asks us, what is our package name? So this is going to basically be, what is the name of our project? So in this case, it's just week 3. That's fine. So if it's in the parentheses, it means that that is the default. If you just hit enter, it will automatically enter that. So I'm just going to hit enter. That's fine. Version. So what's pretty common is we start our versions at 1.0.0. That means that it's the first version. So I'm okay with that. Description. Don't really need one. Entry point. So what an entry point is this is basically where our application starts. What is the first code that needs to be run in order to run the rest of our application? Everything has to start somewhere. So in this case, index.js, kind of see it's a little bit similar to when we have our HTML files, index.html. So we're just going to have index.js as the default. That's fine. Hit enter. Test command. Who cares? Hit enter. Git repository. So if you want, you are able to enter a Git repository into here. I'm not going to worry about it just because when we initialize with Git, it'll be good enough. This is mostly for automated stuff on NPM, so that way when you're browsing, you can figure out where you can file like an issue or even contribute for the open source part of it. So I'm just going to hit enter, not important. Keywords, not important. Author, not important. License, not important. Is this okay? Yeah, you probably don't know otherwise. Yes, it's totally fine. So, okay, so if I ls, I see that now I have one file, package.json. So I'm going to open this in my editor. And you'll see right here, I have week 3 and I have package.json. So, okay, so what's in package.json? Actually, maybe a quick thing. What is a JSON file? So a JSON file is basically, it stands for JavaScript Object Notation, but it's a way of describing usually some sort of metadata or just some sort of information in a normalized format. So it uses JavaScript's objects to describe data. In this case, we have our curly braces saying that this is an object. And then inside of a JSON object, or really any sort of JavaScript object, it's represented by key value pairs. So we have our name that it asked us, week 3, our version 1.0.0, description, which is empty, our main, which is our index.js, or as what was called before, our entry point. We have a scripts, which is, in this case, it's an object with only one called test. We also have our author and our license. So essentially, this is the most basic package JSON that you can pretty much make. Why do we have a package JSON file? So the reason that we have this is when you're working on Node applications, or really almost any sort of application, typically you have some sort of dependencies in it. What is pretty common, and I'm sure you guys have seen in other web development courses, is you might be using jQuery, or you might be using Bootstrap. Bootstrap right now also requires Popper.js. So these are already 3 different requirements for your application to work. So what this does is it allows us to manage the dependencies in our application. So if I were to move this application from one computer to another, I could reinstall all of the dependencies without needing to actually copy those dependencies. It allows us to manage them a lot easier. The other thing is dependencies that we're using quite commonly update. And this gives us a handy way of being able to manage the versions of our dependencies. So as Bootstrap or jQuery or Popper.js update, we can run a command in NPM to see what package or what dependencies we have that are out of date and be able to update them. So let's see. So installing a package. So you might not necessarily know what is a package. Basically, you can just think of it as it is code that someone else has ran or has written that you can install and be able to run. So you can think of it as an easier way of writing your application. If we had to do everything from scratch, we as developers would never get anything done. We constantly, basically, stand on the shoulder of giants where we just benefit from people that have written code before us. So obviously we don't have to write a programming language from scratch. So we're able to use JavaScript and Node in order to run our application. We don't have to worry about it. The same thing goes with running a server. We can just use the HTTPS library or HTTP/HTTPS library in Node in order to create a server, as well as there are people have made it a lot easier to create a server. The library that we'll use is called Express, that makes it even easier to create it. So as time goes on, people realize that sometimes writing stuff is really hard, so they make it so that they don't have to do it in the future because 100% we are lazy as developers. We don't like to do something more than once, otherwise we'll figure out an easier way to do it or to automate it, which is also something that we may end up doing. So the library that I just said that we were going to use is called Express. So in order to install Express into our application, we type in npm install and then the name of the package that we're using. In this case, Express. So when I hit enter, it will begin to install it. And if I have open my package.json, you'll see that I just have something new that just popped up. it's dependencies, and you see right here it says express. Express 4.17.1. So basically I'm using 4.17.1 of the version of Express, and it automatically adds it to my package JSON. So again, the reason that this happens is if I were to delete this node modules folder, I can type in npm install. It will read my package JSON file, and it will reinstall it for me. So it knows what packages I'm using, and it will automatically reinstall them for me. So I guess that brings up another good point, is I just deleted this node modules folder. Where did that come from? So anything that we install as a dependency typically will go under our node modules folder. This is where any dependencies that we're using and sub-dependencies will go. So right now, we've only installed Express. And you might be confused on why I opened it up, and there was so many different folders in here. Surely Express isn't using them all. Well, if I scroll to this folder for Express, and I open up its package JSON folder, because it also has one, I can see under dependencies, right here, these are all the dependencies that Express has. So it requires something called accepts, array flatten, body parser, content disposition, content type, cookie signature, debug, depd, etc., etc. I'm not going to list all of them. But the thing with these is sometimes these dependencies also have other dependencies. So we get this very tree-like structure of all the dependencies in our application, and sometimes, which is a little bit annoying, is they require the same package but at different versions. So there is a lot of different files that will be installed sometimes in our application as we continue to build it. But essentially, for all purposes, the node modules we don't care about until we're trying to either develop our application or run our application. So when we are working with Git, which is of course the best practice of writing for working with our code, is we can use version control to make it so that way we can go back to previous states, or even just be able to host it somewhere else so that we can download it on a different computer. So before I start anything with our application, I'm going to create a new GitHub repository, so that way also if you end up falling behind if I'm going too quick, you can just reference the code online. So I'm going to create a GitHub repository, just like I did last week, and call it COMP2068, fall 2019, week 3, and create repository. So okay, so I've created it. I can just copy these handy commands that are right here into here. So it will initialize our repository like we did with npm init. It's going to add a README file. It will then commit with the message first commit, add the remote origin, and push it up. And that failed. What did it do? Oh, because I didn't actually do it. Oh, okay, so git add dot git commit first commit. Oop, I've already made a mistake. Okay, so remove the .git folder. So I'm going to reinitialize my GitHub repository. So here's the thing with dependencies. We don't need to push them up to GitHub. Reason being is, as I just said, we have our handy package JSON file. This will make it so that we have fewer files that we have to track and fewer files that we have to push up. So if I create a new file, called .gitignore. So you might have seen this before, might not necessarily know what it does, but essentially this is a file that tells Git these are the files, folders, or structure that we can ignore in our application. So in this case, I'm just going to say node modules. I don't care about anything else. I only want to ignore the node modules folder. So now, when I add all my files, and I type in git status, you'll see that the only files that it has found is our gitignore, our package JSON, and our package lock JSON, which I will go in also later on what this is for. So, okay, so now I can commit and just say first commit. And if you're falling behind with doing any of the Git stuff, that's okay. Feel free to just watch along with me. But I will copy the command right here for pushing up to GitHub. So we add a remote origin and then push it up. So now I have my repository. Git ignore, package JSON, and package lock. So okay. So we've done a lot of work and we still don't really have anything to show for it right now. So this is now where we're going to actually start building our application. So I'm going to create a new folder or a new file. And if you remember in our package JSON, we called index.js was going to be the entry of our application. So I'm going to create a file called index.js. And in here is going to be our application. So I'm going to say console log hello world. And we can make sure that our application is working. So I save index.js, and I can, in my terminal, I can type in node index.js. Or in this case, because I have set up the entry point, I can actually just type in node, and it will automatically run the index.js file. Nope, I lied. Gotta type it. Okay. Sometimes there are certain things that you can do in order to make it auto-run files, which we'll go over in a sec. So I run node against my index.js file, and we console log out hello world. So if I were to change this and just say foo bar and run file, now it says foo bar. Now, something that we'll get into in a sec, but if I were to do something else, so we mentioned before blocking and non-blocking code. So if I set up an interval that will run some code every 1 second, and we'll move that console log inside of it. So now, when I run this code, oh, I did set immediate, whoops, set interval. When we run this, you'll see that node does not automatically stop as soon as foobar is done. And it's because our code is still executing. There's still more intervals that need to be run, and this will not actually finish until we tell it to stop. So in order to stop this on our machine, you can hit, if you're on Windows, you can hit Control-C on your keyboard, or if you're on a Mac, you can hit Control, well actually I guess Control. So you can hit Control-C on your keyboard, and it will stop running node. So something that is a little bit annoying in development is sometimes when we're running a server and we want to make a change and we want to see it happen. So in this case, I am going to run our index.js file. I'm going to run it, and I want to change what it's console logging. I want to go back to hello world. And it's still console logging foobar. The reason for this is when we run node, it compiles our index.js file using the V8 engine. So it will compile it and then execute it. So if we make a change to it, it already has all of our code in memory. It's already running it. So any changes that we make will not be reflected in the output of our application. So a little bit annoying to always cancel it, restart it. There is a dependency that we can install that will detect file changes for us and restart node. So another package that we will install, and this is always my go-to package, is I will install nodemon. So nodemon npm install nodemon. You'll see under our package, oh, that one's not ours. Under our package, that we will now get a new dependency once this finishes. Okay, so now we have nodemon right here. So now, if I type in NodeMon, it probably won't work. I don't know if I have it installed. Yeah, okay. So I installed NodeMon, but I can't run it. And the reason for this is that there are two different ways of installing dependencies in Node. There are local dependencies that is inside of our folder, and then there are global dependencies. So I can install NodeMon as a global dependency, and what this will do is it will let me run NodeMon in any file that any file or folder that I want. It doesn't have to be installed as a Node module in that folder. However, this is not always a good way of doing things, because when we go to deploy our application into the cloud, we also need to have a list of our dependencies that we're using. So another way that we can go about this is go into our node modules folder, go to NodeMon, and then if I type in index.js, that might work. Nope. So NodeMon. So in here, it's probably under lib or under bin. Yeah, bin. Okay. So now, if I run, same thing, nodemon /bin /nodemon.js and then index.js. Now we're running it with nodemon. And as soon as I go to my index.js and I change this to foo bar, I'm going to put these side by side so I can save, and it will detect the file change, and then it will restart the application running foobar. So obviously, we don't want to write this command every single time. We don't want to go into our node modules, into our nodemon file, bin, and then nodemon.js. So what we can do is we can write a shortcut. Kind of like writing a shortcut on like your desktop on Windows, we can write a small script that will automatically do this for us. So under our package file, under scripts, I'm going to put dev. And this means that this is the script that needs to be run when we're doing development. In this case, I can actually just type in nodemon. So nodemon index.js. So if I open my terminal again, and instead of running this big command, I can actually type in npm run dev. And I hit enter, and it will now automatically run nodemon against that file. So again, you can think of it like a shortcut that you create on your desktop in order to either access a folder or access a file. It just makes it a little bit easier for us. And then also, when you are sharing this, like for example, working in a group, you don't have to tell them, oh, run this command or run this command. You can just set it up as a script, and then they can just look and say, oh, there's npm run dev. I can just run that. So, okay. So we've set up nodemon, which is good. We have express. So express, like I said, is what will allow us to run an HTTP server. This is what we're going to do so that way we can open up our browser and access our application that we're using. So inside of index.js, I'm just going to remove this set interval, but I'm going to require in a couple different things. So I'm going to create a constant called express, and that is going to require in express. So inside of Node, and I'll try to bump the font size. Is that okay for people at the back? I can dim the lights a little bit more. I know sometimes it's a little bit harder to see. Okay, so Node by default uses what is called COMP2068. So COMP2068 allows us to write code in one file and then be able to include it into another file. So in this case, we require express. So how does it know where Express is? So it's smart enough to read our package file and see that we have a package, a dependency called Express. And actually kind of what it does is it looks under the hood, goes into our node modules folder, and finds Express. So it already knows where to find this. And in fact, in my editor, I can hover over it and see where it's finding the module. In this case, it's a cache, but so I have Express. So I've required an Express, and if you're not sure, like, I mean, obviously I have a lot of experience with Express, but if it's your first time doing it, you can go into Google and go to expressjs.com. So this is the official website for the Express module that we're going to be using, which claims that it's a fast, unopinionated, minimalistic web framework for Node.js. And it has the command that we just ran here with our npm install express. So if it's your first time doing it, you can go to the get started. We've already installed it. We can actually just skip to hello world. And this has an example of just running a basic server. So we already required an express. And then there's a couple other steps here. So I'm just going to actually copy this just because it's already there. So let's explain this. So we require in Express because it's a requirement of our application. So we require it in, and then we create an instance of Express, and we're going to call it app. We then also create a port number. So a port number is what we're going to be using to access our application. In most Node applications, it's pretty common to use port 3000. That's like the go-to standard of most Node applications. Other things that you'll see will use different ports, but it doesn't really matter. Just, I'm going to use 3000. I like to use it. So then we have this app.get. So as you guys know, in writing a server, there are different types of requests to a server. There's GET requests, there's POST requests, there's tons of other ones. But a GET request is what happens when you type in google.com into your browser. It's a GET request. You're basically saying, I want to get whatever is at this resource. And in this case, we have a REQ and RES variable. We're just going to ignore it. But it's just going to send back hello world. So if we go to our application and we get hello world, we know it's working correctly. Then lastly, we have this app.listen. So this is where our application is going to listen on this port. You can kind of see that it kind of makes sense. And what happens is after that is done, we are going to console log saying that we're listening on port, and then we inject the port. So we're going to be listening on port 3000. So okay, so if I run npm run dev now, we're going to get a console log that says example app listening on port 3000. So you can go to your browser and type in localhost 3000. And you'll see right here, I get hello world. So that means that my application is working as expected. It's sending back a response. Now, typically, I like to usually get the class to set up their server and then make changes to it and not understand why it's not changing. But in this case, we've actually already installed NodeMon, so I can change the server, and we immediately get it. Again, if we're running just with Node, not with NodeMon, then we will not see those changes because it's the application's already in memory. But what we want to do is probably do something more than just this. Like right now we're just sending text. But before we get to sending more, what is always good to know is how is Express working? So there's two very basic things, and I would say that this is the most important thing to understand about Express. Like, if you were able to bookmark this time in the class right now, do so. We have two variables that come in from the function. So right here, when we hit app.get on /, this means the index of our application. We have a callback function that is request and response. This is what it stands for. REQ stands for request. RES stands for response. I can actually just name it if I want. I can go request and response and then also use it right there. But this is the most important thing to know. The first variable is the request. So what is the request? The request is what is sent from the client. So this is going to be everything from what URL they're hitting, what browser they're using, what operating system they're using, their IP address, basically anything that you could imagine that a user would send to you through the browser by default is what is included in this. In fact, I will do response.json REQ. Oh, whoops. Okay, so it's not liking that. What if I just send it like this? No, it's not liking that either. Okay. Save that. Okay. So maybe I'll just console log it here. That might be better. Sorry, I'll explain in a quick sec. Response.send hello world. Okay. So let me open up my terminal, and you can see that there's quite a bit of information here. So this is everything from the request object that is being sent. So there's a lot of information. We have some socket stuff, being able to see if they're using sockets, connection socket. Here are their headers. So you can see right here some stuff that's we know is their user agent is using Mozilla 5.1 Macintosh. What else? Accept, so they accept HTML, application XML. We accept images with WebP, PNG, all this other sort of stuff, and they accept gzip, client. So we can see the URL that they're hitting. We can see what method that they're using, which was a GET request. Most of this stuff we don't really need to actually care about right now. But you can see that there is quite a bit of information that is sent. So again, the main thing is that request is everything that is coming from the client. The second object is response. So it's the exact opposite. It's everything that is going to be sent back to the client. So in this case, we have our response object. We are sending back just this string. In this case, it's only going to send back a string. And then, yeah. Okay. So I would say that that's probably the most important thing to know with Express is that it goes request response because sometimes you might end up switching it and then it won't work. Always good to know that. So, all right. So we have our hello world. We've run it. But we want some routing. So routing is where when you hit specific URLs, it ends up giving you different content. So an example would be on the index page. Well, let's do this. We'll have /hello, and then I'm going to create another one, app.get/goodbye, and this is going to use request, response, and then use response.send goodbye. So, okay. So I go to my application, I run it, we get an error, and that's because I removed the index route. So right now if I go to /hello, we send hello world, and when I go to /goodbye, we get goodbye. So very quickly, we can set up different routes in our application. And obviously this is important because as you use different sites, the URL dictates what part of the site that you're on. So when we're using, let's say we're using YouTube. So when we go to a YouTube video, we go to a YouTube video and it has a unique ID for each video. So that way when you want to view a video, obviously it's not going to be the same one. So this comes into what is called dynamic routing. So this is where obviously we're not going to have a big application with every single video hard-coded in the URL. We're going to have some sort of placeholder that will end up being a variable. So in this case, I'm going to have app.get, and I'm going to do /name/:name. It can be whatever you want. You could just do placeholder for now or some sort of thing. But what is important is if we want to use a variable, we end up using colon. So in our response, in our request response, I can console log request.params. And I can go over this in the documentation in a sec, but params are any of the URL parameters that we have set up top. So if I console log this and then just do res.send hello world anyway, if I go to /name/hello and look at here, my request.params is an object. So I have a key called placeholder. So placeholder is going to be whatever gets put in this URL. So I have name, / and then whatever. So you can see up here that it's hello. So if I put /Chris, and I look in here, I can see placeholder is Chris. So what I could do is instead of using res.send hello world, I can say res.send hello, and then I'm going to use that template literal string, so request.params.placeholder. And I'm going to send that. So it's restarted. I refresh and it says hello Chris. So I could also do hello Thomas. That works. I could do hello Frank. That works. But I can also do some more gibberish. So you'll notice that I'm putting some slashes in. Actually, that one doesn't work. Sometimes it does with some other ones. But let's just do any sort of gibberish. So if I do a slash and then do some more content here, depending on your configuration of Express, sometimes it will assume that all of this is one variable. In this case, by default, actually, they must have changed it because at one point it did not do this. It detects this as a new route because essentially, I guess what it's now doing is that it splits on the slash and determines that we're on name, and then let me actually do some stuff so it makes more sense. So it splits and it says we're on the name route, followed by the Frank route, followed by the Chris route. So if I wanted to, I could add in a second route that says placeholder 2. So I can say hello placeholder and request.params.placeholder 2. So if I refresh, now I get both of my variables. So it's not very common that usually, well, okay, maybe that's incorrect to say. In most applications that I have worked on, it's not usually very common to have two variables back to back. Usually what will happen is you will have some sort of prefix at the beginning, maybe a name, maybe it's just, you know, in the case of, let's say Reddit, they use R for subreddits, they use U for users. It's very common to have some sort of prefix followed by a variable. In other cases, you might have more of a structure. So you might say app.get user / whatever. So let's say username, and then maybe you'll have some more content after that. So in this case, it would be details. So this would be a details page for that user. So we have our request, our response, and I'm going to send back res.send the user's name. Oh, I'll just use the interpolated string. That's the other thing that's also really nice about template literals is that you can use both single quotes and double quotes without having to escape them. So I can just say the user's name is, and then say request.params.username. They live in Barrie and they have 2 cats. In this case, we don't actually know this because we're going to say this on every user, but we can just assume that if we go to /user/Chris/details, so the user's name is Chris, they live in Barrie, and they have 2 cats, which is also not true. I don't live in Barrie, but kind of get the idea. So, all right. So it's pretty easy to set up different URL pathing inside of Express. It's very quick. The syntax, at least I find, is very natural, where it's just a string that you give it of what you want the URL path to be. And then the second part is the function that you want to handle both the request and the response. So there's a couple other things that you can do, such as being able to do any sort of like validation on the request parameters, as well as being able to do fall through. So I'm going to show falling through just because it makes a little bit more sense, I think, than using the params. There's not very much that I use for that. So I'm going to show you this, and then we'll actually get into building like a web page. Let's see, how are we doing on time? 8 o'clock, okay. So I'm going to get rid of some of the former code that I wrote and just have our hello world at the base of the application. So let's say you're building an application and you want to have 2 different routes set up. Maybe you want to split how your logic is handled. So an example of this could be we check if the request.params.username equals Chris. Otherwise, we want to do this. So, okay, so we have our request response, and I'm going to send a string says the user is not Chris. So, okay. So down here, I'm going to send request or response.send the user is Chris. So, okay, so how do I access this function? Because right now, if I were to access this part up here, if I refresh, it actually times out. And the reason is that we're never sending back a response, because in our code, it falls in between these 2 if statements and we never respond back with anything. It's not smart enough to know that it should be using this instead of this. So what we can do is there is an optional third parameter. There's request, response, and then next. You can actually call it whatever you want. Typically people call it next. So what I can do is call next as a function. So when I call next, it will actually fall to the next available route that matches that URL pathing. So I can say next, and when I refresh, it says the user is Chris. If I change this, it says the user is not Chris. So this is a way that we can set up multiple URL paths for the exact same thing and be able to switch between different ones to sometimes simplify our logic, so that way we don't have a bunch of if statements. We can just kind of break it up and make it a little bit easier on ourselves. But again, most commonly, we don't want to try to do too many things on the same path because then it will get confusing. So this is just an ability of being able to show off the next operator, but maybe this is not the best way of showing it off. But just to show you, you can have 2 different paths with the exact same value. The main thing to know when we're working on an application is that, our paths are going to be hit sequentially. So in this case, it will just cycle through the first available path that it will find. Because this one is up top, it has higher priority. So right now, if I don't have the username as Chris, it says this user is not Chris. If I pass it in, it then falls through to the other one. However, if I move this code up top, it now has a higher priority. It's going to be the first one that's hit. So if I refresh, okay, that's still working. It still says Chris. But if I remove it and change it to something else, it still says the user is Chris. And it's because it hit that route first, and then it responded back with saying the user is Chris. So the main thing is when we register, this is called routing. So when we register our routes in our application in Express and in Node in general, it's always on a first come, first served basis. So it will hit this route before it hits this one. So if for some reason you want to change the ordering, you just have to move it up and make sure that it's hitting it correctly. The biggest bug that I see with students doing something is that they will be declaring multiple routes of the same name in different files. And they'll be wondering why it's not actually hitting the correct page. You're getting an error. Well, you've been doing all of your logic in a different file, but it's using the other file first. It's responding back quicker. So in this case, just always be aware of when we're registering our routes. Typically, we will use a file structure that has a better practice than doing it all in one file. This is not a good way of doing it, but it's not wrong. This is, in the stages of doing our Hello World and Node. We're just slowly crawling on how to work with Express and Node, so this is not a bad way of getting started. So with that, I'm going to do another 10-minute break. If you want to be here at, again, 8:15, and then we'll slowly start working on actually getting our web page to respond back with HTML. So, yeah, again, if you want to be here 8:15. Thanks. Okay, so as I mentioned just before the break, we're going to actually be serving some HTML files from our Express server. So there's a couple different ways that we can work with files. So one of the most easiest ways to work with files is when we're working with static assets. So what this means is typically you have like a photo, maybe it's a CSS file that doesn't change very often, maybe you just have like an HTML file like an index.html, and we can serve those static files just from the folder. So in this case right here, we use express.static, which is built into Express, and we can say app.use. So app.use is a little bit different, and we'll go over next week on what using actually is. But essentially it uses what's called a middleware. And that middleware will be able to handle any assets and serve them from the public folder. So what I'm going to do is I'm going to create a new folder called public. And I will create a file called index.html. So I have an index.html file served from the public folder, and I'll just use an HTML5 skeleton. So HTML5, and in this case now I'm actually going to do hello world serve from index.html. So, and honestly, whatever's in your HTML file doesn't really matter as long as you know like the structure and put some sort of stuff in there, then that's fine. But in our index.js, this is where we're going to be putting our logic. So we saw in here we use app.use, which is a little bit different than app.get. So app.use, and then we want to use express.static on our public folder, and then save. And in this case, I'm also going to get rid of this index right here. So express.static public, and when I open up our application, go to the index, I get hello world. And it's because it's now taken the route that is being used in my application and now loading index.html from the public folder. So it's basically, it's grabbed that file from public and it has now served it through the index route. I can also do the exact same thing if I wanted to use, instead of app.use by itself, this means from the root of our application. But I can also use app.use on a URL in the same way that we're using up top with our get. So I can just do /hello. And I don't think I'm using anything else for that, so I'm going to save it. And I can do /hello, and we get our hello world. So we can set up different static files in order to access any sort of images or CSS or JavaScript files that we have in order to load it into our application. Now, something that we commonly want to do inside of our project is we want to serve dynamic HTML. We don't want to just serve just some crummy HTML file that is on our server. We want to be able to inject stuff into it. Like imagine I can do /hello and say /hello/Chris, and then we end up serving that name as a part of the HTML. So in this case, if I had /hello/name, if I refresh, we still get hello world. We want to take the HTML and inject the name right here. So that goes outside of serving static files. We're not doing static files. But what we are doing is we're going to be using a templating engine. So you've probably seen in other classes you're using a templating engine. PHP kind of is a templating engine. If you're using C# with ASP.NET, you've probably used the Razor templating engine. If you've used, I don't know, that's pretty good. That's 2 for you. Node has a lot of different templating engines as a part of it. In this case, we are going to be using a templating engine in this class called Pug. And it's actually kind of handy because their documentation is actually showing you how to install Pug. So we can take this command, npm install Pug. Pug does not come with Express by default. And the reason for this is Pug is a templating engine made for Express it's not made by Express. So basically, it adheres to Express's syntax of how to create a templating engine, and you can install plenty of different templating engines. In this class, and I want to make this very clear, we are going to be using Pug. It doesn't matter what other templating engines are out there. There's EJS, Handlebars, all these other sort of ones. We're using Pug. And what's nice about it, I find, is that it has a kind of shorthand syntax for HTML. So we're going to npm install Pug. And this will be the last thing that we do, and then you guys can just go home, so don't worry. So, okay, we've installed Pug. We're good. I wish, it's not that easy. So, in order to use Pug, we actually, inside of our application, we set which view engine we're using. So we use app.set view engine Pug. So what does this do? Underneath the hood, Express has a lot of different variables, like magic variables that get set. And what it does is it says, I'm setting the view engine equal to Pug. So whenever you're wanting to do HTML that we're rendering, we want to use Pug, so look for that. So okay, so we're gonna set our app up here, and it's always good to do it at the top. Anything that we're setting for our application wide is going to be at the top before we hit any routes. So we do app.set view engine Pug. So set up Pug as our view engine, which might be kind of silly to do this. I could only be more verbose by just saying set up view as, or Pug as our view engine for our app. We've already said set, so now we've just reset everything that we just did up above in English. Ooh. And what we can do is we can create a Pug file. So a Pug file is a way of expressing HTML, but being able to do stuff dynamically. In this case, this is what Pug looks like. So you can see that we don't actually have the greater than or less than symbols. It's not tags. In this case, it's just the raw element. So we have HTML, we have head, we have title, we have body, we have H1, and the main thing that's also really important to know about Pug is that it is white space sensitive. So what does that mean? Has anyone here used Python before? Couple people. So as you know, when you're writing Python code, when you want to indent code, or let's say you want code to be a part of a function, any of the code that is indented is going to be a part of that function. If it's not, then it's outside of that function. It's kind of like, you know, it's global. So Pug is very similar. So what we can do is we have our HTML, and then we have one tab, or in this case, two spaces. We can argue tabs or spaces another day. But we have two spaces, and then we have head. So head is a child of HTML. And then we have title, and title is also inside of head. We have this equal symbol. This is now where we're starting to use dynamic stuff, but we can just ignore that for now for the syntax. Then we see that head and body are equally tabbed in. So this means that we have head, or we have our HTML, and head and body are both a child of HTML. Title is a child of head, and H1 is a child of body. So if we open up our editor, I'm going to create a file that's not in our public folder. Make sure it's not. I'm going to create a new file that's going to be called index.pug. And depending on which editor that you're using, you might not get automatic syntax for Pug. If you want to, go into your extensions. I use Visual Studio Code, by the way, for anyone that's not using it. If you're not, please use it. It's awesome. It's one of the best editors that's out there. Sublime is not good. No, I'm kidding. No, I just am a big fan of Visual Studio Code. It's very, well, it's sort of lightweight, but it's it has a lot of very good plugins, and it has a very rich ecosystem. So anyway, so we have our index.pug. So as before, we have HTML, then we have our head, and we have our title, which is going to say hello world, pug. Then we have a body, and just like our HTML file, we're going to have a H1 that says hello world, insert name here. So okay, so we have our index.pug. But how do we access it? And now that we have registered a view templating engine inside of our application, we can also now use a newer syntax. So we can use res.render or response.render. So we're going to use request response, and we want to use res.render, and we'll say index. So here's something that's quite nice. Because we've already said that we're using pug, I don't have to say use index.pug. I can just say render index. And in this case, I'm just going to give it an empty object. You'll see why in a second. But just trust me, we're going to render index at hello/name. So okay, so we have hello/name. Refresh. Oh, we get an error. Cannot look up view in. Oh, hold on. Am I wrong? No, I've registered it. No, shouldn't have to. Oh, yeah. That's why. Whoops. So, okay, so we also set up, thank you for catching my mistake. We set up a folder called view, and we drag the index.pug file inside of it, so we move it. And now, if I refresh this, oh, views, I misspelled again. Look at how awful I am. Okay, views. Refresh, now we got hello world inset name here. I really am awful with spelling. But we get our hello world pug. So, okay, so we've set this up. How do we actually pass variables? So this is the main thing with this class, is JavaScript is really powerful. We can use JavaScript on the front end. We can use JavaScript on the back end. We can pass data using JavaScript. We use JavaScript to now load that. Like, everything's in JavaScript, which, again, for better or for worse, is what we're doing in this class. So what I want to do is I want to pass this name property. So I can say the second option of this res.render, first one is the file. The second one is any variables that we want to pass to the file. So in this case, I'm going to pass the name property. So name, and I want to pass request.params.name. So here's the difference between using pug when we're using our templating engine and using the node stuff right here for index.js. So when we're wanting to access the request parameters, we have to use request.params.name. But when we pass any variables to pug, we don't have to do any sort of special accessors. We can just access it just by its name that we've set here. So we could just do username. It could be whatever we want. In this case, I'm just going to use name, but you can do whatever you want. So inside of our pug.js, this is now where I have to access the name property. So I can just use name. And you'll see that it's the similar syntax, not exactly the same, but similar to the way that we use template strings inside of JavaScript, except instead of using the $sign and then the opening closing brace, we use the hash symbol or hashtag or whatever, number sign, anything like that in order to access this property. There's also another way you can use an exclamation mark, but they do different things. So please, for right now, just use the pound symbol. So okay, I saved that. Now when I refresh, I get hello Chris. So what has happened is, you guys hopefully should be familiar. Who here is familiar with the term MVC? Good. So model view controller. So very quickly, model view controller is a way of splitting up our application. We use models to define how stuff should look, how it interacts. It's really a way of representing our database in the application that we're using. Then we have a controller, and the controller is the way of interacting usually with our model and then passing data to our view. Then the view is just our HTML. It's dynamic, but it's our HTML. And that's essentially what we're doing right here. We've split it up. We're kind of skipping the model right now because we're not doing any database stuff. But index.js is our controller. This is the controller for our entire application. Then we pass data. We could be passing, data from a database or anything else. We could grab stuff off of S3 or any sort of thing. And then we pass it to our index.pug file, which is our view. So this is now where we pass in data and be able to dynamically do stuff with it. Yes?
So can you then, like before, create different controller files?
Yes.
And require them in?
Yeah. So separation of concerns is a really big thing. So if we put everything into one file, eventually, if I were to copy paste this, imagine an application like YouTube or even Google or Facebook, doesn't matter. You're going to have tons and tons of different routing. So you can imagine very quickly, if you have all of your routes all in one file, it gets quite unmanageable. So if I just undo that, okay. So we have this all in one file right now. So let's split this up. Typically, we like to split up our files so that way all of our files that are, say, with /user are all in the same folder or same file. So in this case, we have a user details. Both of them are the same thing. And then we have hello. So what I'm going to do is I'm actually going to make this /user, remove these out. Actually, I'll just comment them out for now. But let's make a different file. So I'm going to create a folder. What's quite common inside Node is that you create a folder called routes. You can also just call it controllers, whatever you want, but I'm going to call it routes because we have our routes and we have our views. So inside of routes, I'm going to create a file that's called users.js. Can be lowercase, can be uppercase, doesn't really matter. In this case, I'm going to call it with a capital U. Actually, sorry, I'm going to do it with a lowercase u because it makes more sense to me. My rationale is always, if it's a model, it should be a capital letter because you're creating something new. Whereas if it's a route, you're not creating a new route, you're just grabbing the routes and you include it in. So here's the thing. When we're creating a new file that we're going to import, we have to do a little bit of boilerplate, very little inside of a route. So just like our application up here, we have to copy in Express. That's the main thing, because we're going to be creating a route inside Express, and we need to use some of the functions that they give to us. Then we create a router object. So router equals express.router. Actually, that should be a lowercase. So express router, and then it's a function, so we execute it, and it returns us back a router object. The last thing that we need to do in this file before we register any routes is we need to export it. So what would be nice is if you could just say export router, but that's not correct. In later versions, which will be nice, you can do export default router, but that's not what we're doing. You end up having to type module.exports equals router, which is a little bit not as nice syntax, but we're going to be using module.exports equals router. Then we get to declare any of our routes in here. So I'm actually going to copy what is right here into our users file. So, and then the other thing that we also have to do is change app to using router. And instead of using use, I'm going to use get. I should have actually switched this over. It was still using app.use from when we use express static. But this is making sure that on a get request, not a post request, not a patch request, only on a get request do we serve this HTML. So this is it. This is everything set up. And now inside of our index file, I can import it. So I can say const user router equals require. And unlike Express, where we require it in without any relative, we actually have to use relative pathing. Otherwise, it's going to try to look inside of our node modules. So I'm going to use a dot, meaning the current folder, slash routes, slash users. So this is my user router. Then I can register it. So I can say app.use. So this means in my application, I want to use user router. And I can save that. So now when I go into my application and refresh, oh, now it's slash user, that's why. Slash user. Now we have our user. So I can set up other stuff in here if I wanted. But what will get quite annoying and repetitive in this file is if I did router.get slash user :name slash details. And did this. So now I have user slash name, and then I have user slash name slash details. Right now it's going to do the same thing. Doesn't matter for this purpose. But I'm duplicating slash user over and over again. So what I can actually do, and I showed you this when we did our express static folder, I can actually say only on slash users, I want to use my user router. And what's nice is now that I've put this right here, slash users, it now makes it redundant to put it in here, because otherwise it's going to be slash, hold on, slash users, slash user, slash name. So now it's just slash name, slash details. So if I put this in right here, slash user, slash Chris, Thomas, Jane, you can see that it's all loading from this folder. And if I were to also change the name, so let's do name plus, and I'll just add details just so that way we know that we're on a different page. I can do slash details, and now we also get that page. So now what we've done is we've abstracted our user information that's in our user router into a separate file, so that way if ever we're working on our application and we need to update something for the users, we don't have this one big file that we're updating. We can just go into the users routes and modify it in there. The big thing that is always important to know when you're working with a new programming language basically is, how do I separate my code into different files and have them work with each other? In Node, it's quite easy to do. As you can see, you can just require it in and just point to the folder. What's also handy is you don't have to specify that it's a .js file. It's assumed. It's not a JavaScript file. You do have to specify it. But that's it. That's how we've done it. I'll throw in some comments just so that way when you go to possibly look back at this on GitHub, there is some comments explaining what we're doing. I had promised that I would do comments today, but I kind of forgot. So yeah, it's kind of being a programmer. We forget to do things. So with that being said, does anyone have any more questions about what we covered today? Anything that maybe didn't make 100% sense, or anything that you just maybe want some extra clarification on? I'm going to assume that you guys are all experts at this, and we will go over this again next week. So don't worry, this is a work in progress. No one becomes a master in a day. As you can see, I made a bunch of really silly mistakes, but going forward, honestly, going through and making this project structure from scratch is very tedious. So next week, we're actually going to automate this process, so that way it's not, it doesn't take 3 hours to build a project. We can just scaffold it, and it's just ready to go. Now, the thing is when you use something that generates it, sometimes you feel like you don't have to know how it works, and it is very important that you know how to set this up from scratch. But yeah, so that's it. You're welcome to go. See you guys next week.
So is there anything we need to do?
No, I was gonna do a lab, but I don't think that we got far enough.
So are you going to continue from here on?
Yes.
Okay, I have to.
Well, we'll restart next week using the generated stuff.
So are we using these files?
No.
So something new.
Yes.
Okay, so I'm gonna redo this because there's no way I can type as fast as you were doing.
Yep.
But I want to get to this point and then I have it.
What did this just 1 second.
Gotcha.
I'm just gonna stop the